right, first things first. Computer radiography, you're going to hear people talk about digital radiography, DR or CR. They are different. Digital radiography is when you go to the dentist office, you sit down, they take a picture, and it pops up on a screen instantaneously. It doesn't go through a secondary step. Okay, that is not computer radiography. It is a different process, so this is going to be focused on CR. So CR is a process by which radiographic images are produced without the use of film per se. Image is captured on a flexible, phosphor-coated, reusable imaging plate. It's exposed inside a traditional cassette. You still have front and back leads. You still have a cassette holder. You got to put it to the shell still or to your pipe. Has not changed. Imaging plate will then be scanned by a laser, and the scanner will produce a digital image, which you can then change, review, view, and annotate and whatnot. You can enhance it, you can filter it, you can make notes on it, you can measure things, you can accept, you can reject on it. It's very user-friendly. It can be shared. Standard radiography, it's hard to email a film. I've done it before. I've put it on a viewer, I've taken a picture and I email that to someone and say, hey, what do you think? You lose something across that process, okay? With the new CR systems, you can email a file instantly. Get feedback. If the person receiving has the right program, he can review, he can filter, he can do the same thing you just did. So you can get a lot more answers. Image plate can then be erased and reused thousands of times. People say thousands of times? Absolutely. If you take good care of it, it's like any other piece of construction equipment, you have to take care of it. If you drop it on the dirty floor, slide it out of your cassette, slam it into your reader, you might not get 1,000 shots out of it. Right now for our lab in Plainfield, Illinois, the first PIPs we bought, or phosphor imaging plates we bought, we're at about 1,200 shots on them right now. And we don't do a lot of production. We do a lot of weld procedure qualification testing and whatnot. It's very useful. Computer radiography, as per rules of ASME Section 5, like they said, Section 5, that's your how-to NDE code. I'm lucky enough to be able to sit on the radiographic working group as well as the ultrasonics, and just got voted into surface examination as well. I'm learning, but this is covered by Article 2, which is your radiography article. Mandatory Appendix 8. It's a mandatory appendix, so if you want to use this, you've got to follow the rules set out in the Mandatory Appendix 8. It is actually medical technology that has come over to the industrial side. Just like digital for your dentist's office, that's also used on pipelines now. It's medical, they do it first, quickest. We like to steal it from them and use it for our purposes. We're okay with that. It's computer-based software capabilities, so wherever you can set up your laptop or your scanner bed, you can use it. Electronic, hard drive, USB, DVD storage. If you've ever had to shoot 20,000 x-rays and store them properly, it takes a bit of time and space, controlled environment. A gold-plated DVD can hold about 5,000 pictures on it, and it takes about the size of that coffee cup. So you save yourself some space there. Three major components of this is the phosphor imaging plate. They're in industry going to be called a PIP. It replaces the film and captures the latent image. You still have a latent image. So radiographers, don't worry about it. You can still talk about the latent image. Nobody's going to look at you differently. You have a PIP reader, or also called a scanner. Replaces the chemical processing steps, reads the latent image. Your workstation, this is now your film viewer. To review, document, grade, store the final adjusted images. Nothing changes. You still have to have a semi-dark room. I'm going to talk about these in a little bit more detail here. The PIP image plate is coated with a material sensitive to ionizing radiation. So X-rays work, gamma rays work, same thing. Exposure to radiation excites the phosphor material and creates a latent image on the phosphor image plate. Excuse me. It is then scanned by a red laser, and the image data is extracted, displayed on the monitor. Your monitor is now an essential part of your system. Your laser is as well. It's usually a closed system. You can't really change too much with it. Image plate is then erased by a bright light and ready for use again. Like I said, some of our plates, we're at shots 1,200 on them right now. We've had a couple we got 200 shots out of because we didn't take good care of them. So, same thing. Step one. Phosphor is going to get excited by ionizing radiation, so you can X-ray or gamma ray. The coated phosphor, those grains will get excited, and they will jump to what's called a halide vacancy and be trapped in here. So once your ionizing radiation is gone, you can't visually see it, but there are some grain things have happened here. You're then going to put this through your scanner. Red laser is going to hit it. It's going to relax these out of halide grains. In that process, there's going to be a blue light emitted. That blue light is then going to be read by some sort of detector. It's going to be given a pixel value. For those of you who aren't familiar with pixel, the pixel term is just a word put together from picture and cell. So a pixel value is a picture cell that's created digitally. And then after it does this, it records that pixel cell. There's a bright white light that will actually erase your phosphor plate and get it ready for next use. Very handy, very easy. Scanning process takes between 20 to 40 seconds. It's the same setup as conventional RT, same sources of radiation. We use X-ray in our lab environment. In our field uses, we use selenium, radium, cobalt, etc. Nothing changes. You still have to expose it. It still has to be sensitive to radiation. We use the exact same cassettes and screens. The only thing we do differently with our LEDs is we don't peel the plastic off, leave it on. Don't need to take it off, why bother? We still have to use IQIs. Still got to prove sensitivity, wire or hole type. It works either way. The statement normally requires less exposure time, KV and MA. Well, we have conservatively figured 25% quicker shot time, so 25% less exposure. Equate that to safety as 25% less time that source is popped open or the X-ray head is full power. Time is money. We're a construction company, so we appreciate that. Eliminates multiple film load due to dynamic range or the great latitude that you can get with a CR system. For a lot of our materials, we don't typically run just carbon steel. We have to run a lot of high nickel alloys. Well, it's basically a carbon steel environment where typically we would have to double load a fast and slow film, maybe get 2 shot times out of it. Now we can shoot 1 PIP, change your histogram, check it out, accept it, reject it in 1 shot. So that saves some time and money as well. Viewing, you need subdued lighting. This would be your darkroom environment this here. You maybe got 10 to 20 foot candles of light, it's okay. You no longer have to worry about chemicals, water washing, or any hazmat materials. It's all done on the scanner. The PIPs themselves are very flexible. You can use them for small diameter pipe. Most of the stuff we build are big tanks and whatnot and bigger pipelines, so it's not an issue, but it is very flexible. Reusable, erasable, that's a key for us. If you have to shoot for one project, a couple thousand shots, for every 100 film you buy, you've bought 4 or 5 plates that you can use over and over and over. You can scan it at normal resolution, very high resolution, depending on what you're looking for. Smaller footprint, like I said, a few thousand films versus a few CDs. I'll take the CDs any day. Image processing time drops from over an hour for manual processing. We have some of our job sites we still have to do manual processing. If you have an automatic processor, it goes 12 to 14 minutes. Maximum I've seen with our CR system is going to be about 60 seconds. And that's taking our time, scanning it, erasing it, storing it, file naming it. So you save some time. Image can be interpreted, annotated. There's various text functions and tools. And then you save it. Instead of using a grease pencil, marking stuff out, you can make notes. Very user-friendly. So if I've made my review and I have to send this to the NRC or to the customer, I've made my notes, my concern areas, it's acceptable or rejectable. I give it to the next guy. He says, yeah, I agree or disagree. He can then readjust that for his own liking. Go on, so on and so forth. Processed images can be shared and exported over about 140 different file formats. You can take that file as a picture, a TIFF. You can do whatever you want with it. Very user-friendly. And then, like I mentioned earlier, email it. That is a key for us. We have projects around the world. As much as I travel around the world, I sometimes like to be home. And I can look at those on my laptop on a weekend, which is great. And then again, like we say, store them on a CD or a DVD rather than archiving in a vault. A vault, you have controlled environment, humidity controls and whatnot. CDs are pretty user-friendly for storage. Still have to load it into the cassette. This is the bigger medical grade style. It's flexible. You can see the bends in it there. You got LED front and back, the typical cassette with the flaps, close it down, keep the dark or the light out. You notice the lighting she's loading that at? It's just like this room right here. It's sensitive, but you don't have to worry about being completely dark, adaptated for 10 minutes to do this. Load it into the scanner. And no, she does not work for us. The scanner bed here, your PIP is put in, white side down, close the lid. In this case, the system that we use, the scanner itself is on its own glass bed, so the PIP does not slide. It goes onto one bed, and the whole bed slides in. So you reduce friction on your PIP. Reduce friction, you use them longer, they stay better. So you load it into the scanner. The scanner itself is a laser scanner. It takes the latent image, or that stored energy of the phosphor grains, and releases it as a visible light. We're not going to see that. That's going to happen inside of that closed loop environment. PMT, which is your photomultiplier tubes, they're going to read that. They're going to take that emitted light and store it as analog signal and then convert it to a digital signal. Several types of scanners. You can get the AC style, which most job sites would be easy to use. Sometimes we have sites where you have to go on battery backup. We can do that too. Resolution, down to 25 microns. I put that up against any film white light viewer. It's pretty sensitive. Adjustable laser and PMT settings. What this means is you can adjust how quick you erase at, how much erasing you do, how much sensitivity on those photomultiplier tubes. So you can be less sensitive or more sensitive. And that just depends on how quick you want those film to cycle through, or those PIPs to cycle through. There's various systems out there. We've tried them all, and there's a couple we like more than some, but you know what? They all do the same thing. They all have photomultiplier tubes. They will all save you some money in the long term. It's a little bit of an initial investment. They're all very user-friendly. If you have a good radiographer, I should have stated this up front, a standard introduction to computer radiography takes about 8 hours. So to do it in 25 minutes here, good luck. AS&T, the newest edition, has a 40-hour requirement if you want to be considered a CR operator, computer radiography operator. But the point is, it's very simple to learn. If you understand radiography, you can understand computer radiography. It's just how you get that image and how you look at it is the only difference here. A little bit of a schematic. There, that would be your PIP here, that one right there. It rolls in, the laser's going to sweep across there. It's going to emit this blue light. Your photomultiplier tube is going to take that, analog to digital. It's going to record that in some sort of a form that I can't understand, but my computer can. Okay, and as it's going through there, the scanner is also erasing it. So it scans it, it reads it, it erases it, and spits it out right where you put it back in. You've now got your digital image, and you've got your PIP or your plate or your film, for lack of a better term, to get reloaded and reused. Now, instead of having a film viewer, you have to have a workstation. That consists of some sort of a reading monitor. Monitors are a little more essential part of the system now. Typical, they're going to be a high-speed computer. These are going to be some big files which are going to have some calculations in there. High-resolution monitor, a 3.5 megapixel plus. They can add up for time or for money, but you know what? It's worth it. You buy a good one, you've got it for years. You need to have certain processing or certain software to process the image. Of particular importance is the security, the file format. It's DICOM, which is, if you're familiar with the medical term, it's DICOM. That's the medical security on that file storage. So when it's used for NDE, we stole something, took the first part, the DICO, put the NDE on the end, call it DICOM. Film secure. Window leveling, so you can adjust brightness and contrast. You can't just turn up your bulbs on the viewer now, you can adjust pixel intensities. IQI sensitivity, you still have to have a certain sensitivity in the area of interest. No brighter than, you can adjust that, you can zoom into it and find out exactly what it is. You can filter it, you can measure it. You can calibrate your measuring. It doesn't really show up well here, but what this is something of a known size diameter. So every image, if I've got that known shim or ball or hole, I can then use that to calibrate my image. So no matter what zoom I use, if I want to measure something, I've got it calibrated to that film. Every film is recalibrated itself. It takes about 2 seconds to do that. I click at the top, click at the bottom. If it's 1 inch, I say 25 millimeters or 1 inch. Then everything I measure based off that calibrated reference will then be referenced. Very user-friendly. I don't know about you, if you've ever had to look at a couple hundred radiographs, black on white, white on black, I mean, I'll tell you what, if you can invert those images, things that after about 150 started to look very similar, you invert that, now your crack shows up as a nice white line, that's handy. It helps you, it actually helps reduce eye strain. So the ability to switch negative, positive imaging, very handy, very user-friendly. Conventional viewing versus a filter view. What we've done here is you put this through what's called a filter. It's just an algorithm. It takes those zeros and ones of that bitmap image, and it creates what's called an embossing filter. So that gives you some true depth measurement. I don't know if you can really see that there, but my picture here, I can see undercut. And typical conventional RT undercut, yeah, it's a shaded line. Well, when you can see it and see the depth in that's kind of handy as well. Histogram feature used to ensure proper exposure was obtained. Whoever does a lot of photography, and we have guys who adjust their histograms based on the background lighting, beyond my scope of taking a picture, point and shoot. But we can adjust the histogram to make sure we've got the right pixel intensities in our area of interest. If we don't like it, we can then pick one side of that histogram, broaden it out. You get more latitude out of that. Greater your latitude, less reshots you're going to have. Very handy, very user-friendly. Zoom feature, if in doubt, check it out. Well, this zoom feature here, you can, I don't know if it shows up good on that, but you can see 1, 2, 3 wires clearly. Sometimes you think you might see a very small linear indication. Zoom in, check it out, it blows it up. It allows you to see it. If you want to save the zoomed image, you've got that opportunity as well. Monitor verifications. The monitor is now a critical part of your hardware package, like the transmitted light. The viewer is to conventional. You don't have transmitted light on this, now you have pixel intensity. But typically a monitor can degrade over time, the lights will burn out, and your pixel brightness can become dull. So the shades of gray test is no longer going to be required for an operator. Instead, a standard monitor test may be used to ensure the image quality is acceptable. SMPTE, Society of Motion Picture and Television Engineers, has a test pattern that may be used. I don't know if you can really see it here, but what we're looking for, you have a 0 to 5% difference and a 95 to 100% difference. If you can see those, see your 4 corners, you got multiple lines going different directions. That proves over the face of your computer monitor, you've got your definition, you've got your sensitivity, low end, high end. Start of the shift, you start that. End of the shift, you check it again. If you got it, you're good. And again, what you're looking for is 0 to 5 and the 95 to 100%. You see a difference? If you don't, maybe you should stop right there. If you do see a difference, carry on. Check your monitor at the end. Same results, you're good to go. Presently, SMPTE is not yet recognized by ASNT or ASME, but it may be soon. I know we've talked about it in Section 5 Working Group RT. I think it got dropped pretty quick. I suspect something is coming now. Here's your storage device. You got a couple hundred film on one CD or one DVD versus a cubicle full. And you can store those. I mean, you can always store the standard file, but if you want to email those, you can store them as a PDF. You can store them as a TIFF file or a JPEG. Very handy. Some of the pros and cons, obviously, the system like this, they're not cheap. You have to spend some money up front to get this system. You got to be able to dedicate a very specific room or an area on a job site or a shop to have your system stored, your scanner, your workstation, your PIPs. The good news is technology is always getting better, and with that, the prices will go down. Sensitivity still goes up. The speed of the PIPs is going up as we speak. I mean, when it came out in big time 5, 6 years ago, one phosphor plate cost about $1,200. Now you can buy one for about $200. There's a difference. The speed has increased. Sensitivity has gotten better. Reduced hazmat, that's a selling feature for anyone. Less radiation exposure, less chemicals, no hazmat. Reusable PIPs, so you don't have to worry about reclaiming silver. All right, you don't have to worry about getting rid of your film afterward if you don't want it, the customer doesn't want it. Reusable PIPs. And there's the legal S. That about concludes my presentation. Thank you very much.
Thank you very much.
Thank you.